Simon is talking about colors, and he was explaining how you calculate brightness
and saturation. Use a little bit too complicated
and
because
saturation.
you have to like figure out different parts of the rainbow, and when there's in one part of the rainbow, you have to do this calculation, this calculation. So that's a bit too complicated.
But this is, I wanted to hear this last part, how you calculate saturation, because that sounded quite interesting. You said that you have to...
So saturation being how colorful is a color. So...
Yeah. How intense.
Meaning, is it really colorful? Or is it really grayscale?
Yeah.
So
So how do you calculate it?
So, it's quite interesting. You actually have you calculate the distance between the actual color and the brightness of that color.
But I don't really understand the way you wrote it. You write distance. That I understand that is distance. But then red, green, blue.
Brightness.
But what distance between the color and its brightness?
Yeah.
Ah, this is the way you write a function for distance? You just list all the things that have to be...
So this is XYZ1 and this is XYZ2.
Ah, you never said that.
So if you think of the three-dimensional space as like a color space for a second, you know,
What?
You know where X is red, Y is green, and Z is blue.
Ah.
This is actually true. And with the grayscale color, red, green, blue is always the same. So I'm just gonna.
So basically,
how far apart the most colorful version possible, and the grayscale version possible. Is that right?
No, how far apart?
So brightness always has, it's never ever gonna be different. No matter what, it always has a value 0.
What do you mean? No matter what, it always has.
So brightness.
Oh, you mean in the least saturated.
And red, green, blue. That's how much saturation you want. So this between that color on this bar, so to speak, and 0, right?
And that value, red plus green plus blue divided by 3. So that's like the average. Is that your hue or is that your brightness?
That's the brightness.
That's the way you calculate brightness. And then you calculate that, and then you have to subtract that, which is going to be the same value for X, for Y, and for Z, right?
Yeah.
And you subtract it from the X, the Y, and the Z, right? 3 times. Did I understand it right?
I don't know what you mean before.
Well, brightness is going to be the same, right? All the three values are going to be the same.
Yeah.
Because it's just the average.
Yeah,
So
that will have saturation of 0. So whatever.
No, it's not always going to be 0.
Brightness.
It's not always going to be 0. You calculate it that way. Red plus green plus blue divided by 3.
No. The saturation of that color is always going to be 0.
Of which color?
Of a grayscale color.
Of a grayscale color?
Yeah.
Of this light gray?
You're
talking about this.
Saturation of a grayscale color is always going to be 0.
No, but I'm talking in general about applying this formula.
And the diff and any other color is... Anywhere where the color is on this bar, so to speak. So if you calculate the distance between that saturation value and the 0, we're also going to get that saturation value back.
Can you give me an example? I think it'll be more clearer.
So if we have
give me a color.
If we have red, I'll say the value is red. So 25500.
Can you write it down?
Okay, so
can you write it down? It's going to be much clearer if you give an example.
Bracket.
Mm-hmm.
So 250. Let me just use this black marker here.